So here in this problem, we need to express each of the following sets in tabular form. So the sets are given in the set builder form. So let's try to first understand problem number 1. So here we have a set A which contains the elements x such that x squared is less than or equals to 10 and x belongs to the set of integers. That means we have to list out all the elements belonging to the set A with the condition that x must be an integer. So we'll only pick up integer values first, and also the way we choose the integers are very important. So for the integers must be such that when we square those values, it must be less than or equals to 10. So we know that by definition, Z will be the set of all integer values. So we have the negative integer values such as -4, -3, -2, -1, 0. And we have the positive integer values 1, 2, 3, 4, and so on. So let's say we first pick up x to be equals to -3. So when we square this value, we're going to get positive 9. So squaring -3 gives us positive 9, and clearly 9 is less than 10. So that means this is an accepted value. Similarly, this holds true for x equals to positive 3 as well. So that means when we take positive 3 and square it, we're going to get 9, and that's also going to be less than 10. So x equals to -3 and x equals to 3. These two values are going to be included in the set. Then we can take x equals to plus or minus 2 because squaring it gives us 4. Squaring x squared gives us 4, and that is going to be less than 10. Similarly, we can take x equals to the positive 1 as well as -1, and when we square that, we're going to get positive 1, which is going to be less than 10. And we can take x to be equals to 0 as well, because squaring 0 is 0, and that's a value which is less than 10. However, we cannot take any values which are less than -3 or greater than positive 3. For instance, let's say if we take x equals to -4. Then if we square x, then we're going to get positive 16, and clearly 16 is not going to be less than 10. So that's not possible. So 16 is not less than 10. So that means we can only take values -3, -2, -1, 0, 1, 2, and 3. So that means we can now express our set A in the tabular form as the set containing the elements -3, -2, -1, 0, 1, 2, and 3. Fine. Let's go to the second problem. Now here we have a set B containing the elements x such that x equals 1 over 2n minus 1, and n is going to be less than or n is going to be greater than or equals to 1 but less than or equals to 5, and n belongs to the set of natural numbers. So here, since n belongs to the set of natural numbers, we can take only those values of n that are natural numbers, and it has to lie between 1 and 5. So we can take n equals to 1, we can take n value to be equals to 2, we can take n equals to 3, we can take n equals to 4, and we can also take n equals to 5. Okay, now for each of these n values, we'll try to find out its corresponding x value. So when n equals to 1, then x will be equals to 1 over 2 to 1 divided by 2 times 1 minus 1, so that's going to give us 1. So x will be equals to 1 whenever n equals to 1. So when we have n equals to 2, then x will be equals to 1 over, we have 2 times 2 minus 1, and that's going to give us 1/3. So when we have n equals to 3, x will be equals to 1/5. When n equals to 4, x will be equals to 1/7, and when n equals to 5, x will be equals to 1 over 9. So that means the set B, when expressed in its tabular form, then we list out the elements 1, 1/3, 1 over 5, 1 over 7, and 1 over 9. So these are the values of x such that x meets the criterion that it's equals to 1 over 2 and minus 1, where n is a natural number and its value lies between 1 and 5 with the extreme values included. Let's go to the third problem. So here we have a set C containing the elements x such that x belongs to the set of natural numbers and x lies between -½ and 9 over 2. Okay, so let's start with the condition for x. It's given here that x lies between -½ and 9 over 2, but we can rewrite -½ as -0.5 and its x value is going to be less than or equals to 9 over 2, that means 4.5. However, it's given here that x belongs to the set of natural numbers. So that means with this given condition, we can pick up only those values of x which are natural numbers. So this means that x can take the value 1. Because x is a natural number, we'll have to start from 1. Then the next natural number that we can pick up, that's going to be 2. We can also pick up 3, and then we can pick up 4. However, we cannot pick up 5, because if we take x to be equals to 5, then 5 is not less than 4.5. 5 is greater than 4.5. So these are the only 4 natural numbers that we can consider. So that means the set C containing, therefore we can finally say that the set C contains the values of x. So what's x? X are the elements 1, 2, 3, and 4, with the condition that these 4 numbers are natural numbers and they lie between -1/2 and 9 over 2. So let's go to the fourth problem. So D is a set containing the elements x such that x is a vowel in the word equation. Now that's a very simple problem. All we have to do is pick up all the vowels in the word equation. So we have E, we have U, we have A, we have I, and we have O. So these are the 5 vowels that are present in the word equation. Let's go to the fifth problem. So we have a set E containing the elements x, where x represents the month in the year not having 31 days. So we have to list out all the months in the year that does not have 31 days. So we can start with February, then followed by April, then we have June, then we have September, and then we have November. So these are the 5 months that does not have 31 days. Let's go to the final problem. So here we have the set F containing the elements x such that x is a letter of the word Mississippi. So here we have to pick up the letters are contained in the word Mississippi. Now as we can see here, now some of the letters are repeating here. So whenever the letters are repeating, we do not consider the repeated ones. We only have to mention one of the letters. So that means we'll start with the first letters, that's M. M is only repeated once, so that's fine. Then we go to the second letter, that's I. But here we can see that I is being repeated 4 times, so we'll only consider one I. Similarly, we go to S. So S is also repeated 4 times, but we will only consider one S. And then finally we have P. P is repeating twice, but we'll consider one P. So these are the 4 letters M, I, S, and P that are included in the, or that are present in the word Mississippi.